Welcome back. We're learning how to use spreadsheets to analyze physics data, and in part 7, we're going to learn how to graph your data and use regression tools. No one likes to look at a big, massive table of data, and what we'd like to do is we'd like to be able to plot the data and be able to visualize it and then use some regression tools to actually see if we can pull some meaning out of the data. All right, let's see how we graph data in here, and I'll also show you some regression tools that Excel has. And once again, the graphing tools and the regression and data analysis tools are much more comprehensive on Excel, and they're very rudimentary on Google Sheets. And let me just give you a reminder, nobody likes looking at a big table of data. We want to analyze that data by graphing things typically. If you don't mind, I'm going to start by making this text here a little bit smaller since we don't need to know as much about the details of the numbers. So I'm going to hit the Control key and use the scroll button on my mouse to zoom this down. I can also use the View tool to zoom in and out if you'd like to under the View pane. I'm going to create my graphs over on the right side of my sheet here. And I would like to, and you notice when I zoom down, I lost my time. These pound signs just mean that the number is too big to display. It's too large to fit in this little width. So I'm just going to widen up my note there, just like so. So you can tweak things a little bit. But over in this space, I'll actually put my graphs. You'll notice right now I have a little dotted line coming down here. That's actually showing where my page is going to break off if I were to print this. And if I scroll down, oh, this is pretty nice. Everything fits. This is just random luck on my part. Everything fits onto one page for my data table. You can manipulate your page layout, and you can actually force where these pagination points come in by inserting page breaks and by setting your print area, by setting margins and so on and so forth, just like you would on a Word document. But all your pages do show up here, and if I zoom out a little bit more, you can see each one of these is a page that would print if I were to hit the print key. The program only prints pages that have something on them, so your printer would only print this first page here, but as soon as if I were just to type one number, let's say over here, then it would print all these pages. This page, blank, 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 and then there's one over here. So don't toss random stuff in or else you get 80 pages coming off your printer. So we'll actually put our graphs right next door here. I could also make our graphs on a separate sheet down below here. I could click into a new sheet to create our graphs based on the data from the previous table. But I'm just going to throw everything on the same sheet, and I'll just use pagination tools so I can print things out nice and neatly. So let me show you how to do some graphing. So I'm going to create a position versus time graph. This will go back to the reason why I decided to put time in my first column. So let me highlight what I'd like to plot here. To start with, let's go ahead and pick up the time in our original position in centimeters. Now you notice when I highlight this, I'm going to pick up my two column titles, and you'll see why I did that in a second, and all my data below it. Now I can insert a graph, and the type of graph that we typically want to pick is a scatter plot. I mean, basically that's just picking your points as coordinate pairs to go on an XY axis, or in this case a YT axis. All right, so I hit scatter, and I can actually click on the graph that gives me just the points, plots just points. It could plot sets of points connected by curved lines. I could just plot the curved lines and not show the points. I could plot points that have straight lines between them instead of curved lines, and so on and so forth. Let me just plot the points themselves at first, and there's my graph. How easy was that? You can go up here, you can change colors and so on and so forth. I can also right click into this, and I can change all sorts of things about the graph. I'm going to use some other features in Excel though. Here it gives me different layouts for these charts. Let's just take a look what the different layouts do for me. This one gives me titles on both our axes. This one gives us data values as well as the titles, and it gives us another type of graph. This one gives me a nice grid behind it, and it does a line of best fit on my curve, which I don't want. But I like this graph in the background. And it turns out I can actually take this line of best fit, just click on it and delete it if I don't want it. Well, the only thing I don't like about this is it doesn't pull in a title for me. And there's a way to add the title on top. So I'll make this graph myself. That'll be a nice exercise to show you how to do that. So I'm just going to click on this graph because I want a title. I want my axes to have their own titles, and I want to have this actually provides me a key as well that shows me what all my color codes are. I'm only graphing one set of data here, so don't really need that. But I can just click onto these things. So this is my position versus time graph maybe. And then I can just click on this title over here, and this is my Y values. So we can click on these, we can organize things, we can change values if we right click on some things. But once again, I don't actually want this to look like a ball moving up in the air because it's not. And I'm really wondering why I have one data point that's off here. And that's probably a mistake I made when I copied down my data. What I really want to plot is my time versus my position in meters, which was this column over here. So let me show you how to do that. So let me delete this graph. I'm just going to click on it and delete it, and let's try this again. I'm going to select my time column, and then I'm going to go over, I'm going to hit the control key, I'm going to hold down the control key, and I want to graph the Y column. Now I'll hit my insert again, and I'm going to get a scatter plot, and there's my ball falling. Alright, and once again I can start manipulating titles and everything else. Well, really what would be even more interesting is to plot not my experimental versus time, but both my experimental and my theoretical. I can compare them to each other. So let's try that. So I'm going to delete this again, and let's try this again. I'm going to hit my control key, I'm going to select my time, here's my experimental Y value, and here's my theoretical Y value. And so now I will hit my insert scatter plot, and there's both sets of data. So my theoretical values should drop, and I can adjust the size of this. You can see maybe a little bit more clearly what's happening. So if it was free falling, I'd see these red dots here, and if it's but in our case it doesn't look like it's quite free falling. In fact, it looks like the curve is flattening out a little bit, almost like we're hitting some sort of terminal velocity, and there is an explanation for that. These red, I don't really like these red squares, so if you click on it, these are called data series. I've got two series of data I've plotted, my theoretical data and my experimental data. So I can click on either one of these, right click, and I can change, for example, the color of these things, whatever color, make it bright red. If I go under Format Data Series, I have a lot more control, and I can change the type of marker. For example, I can click off of one of my built-in markers. I can make little circles instead, change the size here. I can either fill it with a color, I can have a line around it. Actually, this is a line connecting my data, so you can see I just put a line in my data here. And so I can manipulate my data in my chart any way I'd like to by doing that. I don't actually like connecting my data with lines, and I'm going to make these data points a little bit smaller. Actually, let me move this over here. I can actually shift things around inside of here. And I probably want to set up with a chart title. So let me move this out of the way. I can spread this out a bit. Manipulate that a little bit. Add some titles in here. If I don't like how my axes are being laid out, I can actually hit right click and hit Format Axes. So using the right click to do formatting on different things is very useful to do. Alright. So that's my position versus time. I could repeat that process for velocity versus time. Let me plot position, velocity, and acceleration all on one graph and see what happens. So here's time. I can hold down the control key. I'll do all my experimental values. Here's experimental position. Here's my experimental velocity and my experimental acceleration. And insert scatter chart. I've got something funky happening with my acceleration. If I go down to my acceleration numbers, my experimental acceleration numbers, you'll notice I have some very large numbers that are showing up someplace in here. And you'll notice if I click on this data set right here, it actually highlights it over here. So I'm going from here. Let me change my axis here. Format axis. Number. I don't want 3 digits. I want no digits for this. All right. So for some reason our acceleration is going up to 500. Well, that's because I had that one point that jumped up off my graph you saw up here. So in order to do that, I'd have to have a massive acceleration that happened. And that's why that's happening. So that data is a little bit messy. So when I try to plot all my data on one graph, it unfortunately is looking really messy because everything else gets compressed. These are the other data sets for my position only goes between 0 and 1, and those numbers are very small compared to the 0 to 500. So let me just delete the acceleration data off here. That's easy to do. Watch this. I can just click on this series and hit delete, and it pulls that out of my graph. And now I'm actually plotting. Here's my position versus time data, and here's my velocity versus time. You can still see, because of that one point right here that I measured wrong, these data points are messed up on my velocity. Actually, let's go and let me show you. This spreadsheet is what we call a formula-driven spreadsheet. And so if I go in and I find this data point that's a little bit off here, so let me bring it down to 74. Whoops, wrong point. This is 73. Because I'm assuming the 7 and the 5 are right, just the number in between. So it's probably 72.5 instead of 77.5. And my 2's do look like 7's, and that probably explains why that happened. And so our data looks a little bit smoother here, and our velocity data is a little bit smoother. And now we can start analyzing the data and seeing what's happening for our position, velocity, acceleration graphs. So here's a graph of position versus time for the mass dropping. I've tweaked my axes a little bit. I didn't want to have so many decimal places, so I actually left click to select the axis, and I right click. I can format axis, and I chose numbers, and I chose a single decimal place for the position axis and 2 decimal places for the horizontal axis. The other thing you'll notice that I can do, if I would like, I can add grid lines. So for example, right now I have major grid lines at these major values, but if I wanted to, I could actually add intermediate values in as well. And I could do the same thing for the other axis. I could add major grid lines. Maybe we can hit automatic on that as well. And if I wanted to put minor grid lines in there, I could do that as well. Feel free to experiment with that. I'll put in my minor grid lines as well in this. But at some point you might get too much clutter in here, but this doesn't look bad. So in terms of analytical tools to use to analyze these shapes, Logger Pro is actually a much more powerful tool because it has many more different options that you can use to fit curves or lines. And the other thing that Logger Pro has an advantage over Excel is that, for example, to me, this looks like, for the actual experimental data, it looks like I have a curve here, but then it looks like it flattens out. So I could actually select the data I would like to fit to a curve and try a curve to that, and then select another set of data over here and fit a line to that. And because it looks like at some point I'm actually sort of like a skydiver falling, I'm reaching some sort of terminal velocity potentially. And if you try this experiment, you can figure out why that might happen and how you can counteract that. I'll show you really quick. If I were to try to fit this with a line, I can just right click. I can add a trend line. That just added a linear function for me, and which is not what I want. So I can switch it over to a second degree polynomial. And you'll notice for the second degree polynomial, it does go somewhat near my data. Actually, I'm above here. I'm below my data points here, and then I switch to above over here as well. So it's not a very good fit. I could actually help a little bit by maybe setting my intercept here. It should start at 1. So I'm going to set my intercept to be 1. And I can actually, on my chart, I can actually display the equation, as you can see over here. And let me close that, and we can move this around a bit. I'll put this up over here, and maybe I can do a fill on the box so I can read the equation a little bit better. Maybe let's put a square around the box. Okay, so there's the equation for that polynomial fit through there. On my theoretical data, that should be a perfect fit because that was based on equations. Let's see if that works. Let's add a trend line. It should be a second degree polynomial. That's what we use for our fit. We will put on here our equation just as we did before. And let's see if we recognize this equation. Alright, so negative 4.9 x squared was really a t, minus 4e to the minus 14, that's a 0. That's scientific notation they put in there, so that's a 0. So we got negative 4.9 t squared plus 1. And sure enough, that's our equation for that parabola for a ball dropping from 1 meter. So that's what it theoretically should do. This is a second degree polynomial fit for this, but like I said, because I see it's going below my data here and above my data here, and it really looks like this is more so linear, you really got to question whether or not this is the best model to fit our experimental data. One more thing you'll notice is that our key sort of has disappeared here. That's just because we've got more in here. It's just hidden. So I'm going to readjust this box, and there's a key that matches our graph. So I'd like to create a velocity versus time graph based on my secants that I use for my velocity approximation, and do the same thing for acceleration. And because I have a nice format here in my graph, what I could do is actually make a copy of this entire graph and then just change the data that it's pointing to. And I'll show you how to do that. It just saves us some time and trouble. You could do it from scratch again though. But this would keep everything. I'd have the same time scales and everything, so it'll make it very easy for me to redo this. And to copy this, all I did is I held down my control key, or if you have a crapple, you can hold down the Apple key. Then I clicked on my graph and I dragged it, and when I let go it made a copy. Or you can cut and paste, whatever you like, to create your copy of the graph. So now all I need to do is point Excel towards the right set of data. Rather than plotting position, I would like to plot velocity. So I'll show you how to do that. Under Chart Tools, you'll notice on Excel at least, I can go under Chart Tools. I can actually hit the Select Data tool. And if you're in OpenOffice, you might look for some sort of chart wizard tool that will pick up the same type of information. And you'll notice right now, if I slide my window bar over, you can see a box around my time axis, my time data, my Y experimental data, my Y theoretical data. You see this dotted box that's floating around each one of these to show you what I'm pointing at right now. And what I'd like to do is shift from the Y over to VY, which is in row E, move it over to column E, move it over to column F. In the same sense, I'd like to take this Y theoretical and plot VY theoretical instead. So I'd like to take column H and change it to column I. And right down here you can see this is where I've defined what data I'm using to create this chart. If you click into it, well, there's column B for my time data. Here's column E for my position data. I want to change it to F, so I'll just take these two E's, E12, change it to F12, and change it to F41. And you'll notice these are absolute references they're putting in here with the dollar signs. And my H's, right here I have an H, that's going to change to an I, column I, another column I, and I'm going to hit OK. And there's my velocity data. Now, the one thing I need to do is figure out how to get rid of these trend lines that I put in before. I can delete the boxes at least. And if you notice, I clicked on my trend line and it selected the trend line, so I can delete that trend line. And you'll notice that I have all negative numbers here. And you'll notice my times, because I copied the chart, my time's going to align pretty nicely here. Maybe I can move this out of the way. I can maybe compress this a little bit. There's my theoretical. Of course, we expect this to be linear. And my experimental, as you can see, from here to about here, it looks fairly linear. It looks like it got a jump here, but that's probably a measuring error on my part. And then it starts getting very flaky, but this is where it starts flattening out. So maybe I want to try to do a line of best fit through this data, even though I'd really only like to do this top portion of it, but I can't do that in Excel. I've got all or nothing. This is once again where Logger Pro is a little bit better. So let's add a trend line, and this automatically is picking a linear function for me. I'm going to force it through 0 because this should be going through 0. And like I said, it'd be nice if I could just take this data up to about, what's the time on this? Up to about 1/4 of a second and just use that. But it is what it is. This is what it gives me. So here's my equation for my data. And then I can adjust where I would like my titles to clean this up a little bit. The minor grid lines are a little bit too much, so I'm going to put no lines for my minor grid lines here. Our value for this function, this linear function, should be negative 9.8x. And we're not, crazy out of the ballpark. We're at about -7. That's not too bad. And if I was tracking the first portion of this data, it'd even be closer to negative 9.8. So our data isn't crazy off. We've got negative 3.05 versus negative 4.9. And so we're in the ballpark. This is showing us about a negative 7.1 meter per second squared acceleration if it was a constant acceleration. All right, and you can do the same thing for your acceleration graph as well. My number should be at negative 9.8, and you'll notice my scales here go from positive 60 to negative 60 because using my slope of a secant between 2 points, I'm getting any slight variation I have in my measurements gets amplified every time I take a derivative, so I'm getting really bouncy data. But if I were looking at the first set of data here for the first half the time, you can see my data is not too bad, and it's bouncing on the negative side, and perhaps I'd be down, I'm bouncing around my negative 9.80 line here that you see in red. But as I get further and further out, all my perturbations get exacerbated and really start bouncing around. So it looks like it's horizontal, so it's somewhat constant in terms of its average values if you look across this. But of course, I've got errors that I'm amplifying in here with my simple calculation that I'm coming up with for acceleration using slopes of